Hello students, today we will be continuing the exercise problems from trigonometry chapter. Let's see exercise 21a. Tan square a minus tan square b equal to sin square a minus sin square b by cos square a into cos square b. Let's take the LHS. Tan square a minus tan square b. How can you write tan a? Tan a you can write it as sin a by cos a. So the same thing you can write it as sin square a by cos square a minus sin square b by cos square a. So what is the LCM? Cos square a cos square b. So when you cross multiply it, you will get sin square a cos square b minus sin square b cos square a by cos square a cos square b. We need the output in terms of sin. Okay. So how can you write cos in terms of sin? So cos square is nothing but 1 minus sin square. So cos square b, we are rewriting it as 1 minus sin square b. And here cos square a is 1 minus sin square b. Then we are multiplying inside. So this will become sin square a minus sin square a into sin square b minus, when you multiply minus sin square b to the inside, minus sin square b, minus into minus, plus sin square b by cos square a into cos square b. So here minus sin square a sin square b and plus sin square a sin square b will get cancelled, and the remaining is sin square a minus sin square b by cos square a into cos square b. So hence prove the RHS. Let's see one more problem. Sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta equal to tan A. Let's take the LHS. Sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta. What is common in the numerator? It is sin theta. So we will take the sin theta outside. So this will become 1 minus 2 sin square theta. And the denominator you can take cos theta as common. So the denominator you can rewrite as cos theta into 2 cos square theta minus 1. Let's simplify again. So we'll take the inside 1 minus 2 sin square theta. So how can you write 2 sin square theta? Sin square theta is 1 minus cos square theta. So the same thing you can rewrite as 1 minus 2 into sin square theta is 1 minus cos square theta. So when you multiply 2 inside, you will get 1 minus 2 minus into minus is plus 2 cos square theta. So 1 minus 2 is minus 1. So this is nothing but 2 cos square a minus 1. Okay. So the same thing you can rewrite as sin theta into, instead of 1 minus 2 sin square theta, we can write it as 2 cos square theta minus 1. So again, if you see here, now these two terms are common and you can cancel out, and the remaining is sin theta by cos theta, and hence prove the RHS. Sin theta by cos theta is what? It is tan theta. Let's see one more problem. Cos A by 1 minus sin A equal to secA plus tan A. So here let's take the RHS. What is RHS? SecA plus tan A. How can you write secA? SecA is 1 by cos A and tan is sin by cos. What is the LCM here? It is cos A. As the denominators are same, you can write like 1 plus sin A by cos A. So how will you proceed from here? You need to multiply 1 minus sin A to the numerator and the denominator. So when you see the numerator, it is in the form of a plus b into a minus b. So the same thing you can write it as 1 minus sin square a by cos A into 1 minus sin A. The numerator we need it in cos theta, right? So 1 minus sin square a is cos square a. And if you see this cos and this cos, you can cancel. So what is remaining now? It is cos A by 1 minus sin A. So hence prove the RHS. Let's see one more problem. Sin A tan A by 1 minus cos A equal to 1 plus secA. Let's take the LHS. Sin A tan A by 1 minus cos A. So as in the previous example, so here also we will multiply with 1 plus cosA to the numerator and the denominator. So here in the denominator, it is in the form of a plus b into a minus b. So the same thing you can rewrite as sin A tan A into 1 plus cosA by 1 minus cos square A. What is 1 minus cos square A? It is sin square A. And tan you can rewrite as sin by cos. So this will become sin square A by cos A into 1 plus cos A by sin square A. So this sin square and this 2 sines will get cancelled, and what is remaining here? 1 plus cos A by cos A. So as the plus symbol is in the numerator, you can split this term as 1 by cos A plus cos A by cos A. What is 1 by cos A? It is secA, and cos by cos is 1. So 1 plus secA. Hence proved the RHS.